In chemistry, we learned that the terms to describe the building blocks of things are atoms and molecules. But then your chemistry teacher says element, and you're like, what? The best way to understand what an element is to define this term while looking at some examples. An element is a substance that cannot be converted or broken down into two or more smaller substances using a simple chemical process. For example, let us look at the element iron. If you take a rod made of pure iron and break it in the middle, you will have, well, two smaller iron rods. And similarly, if you heat iron to 1538 degrees Celsius or 2800 degrees Fahrenheit, you will be left with molten iron. Or if you turn up the heat to 5183 degrees Celsius or 9361 degrees Fahrenheit, you will have gaseous iron. Whatever you did there, the end product was always a slightly different or smaller version of iron. And that applies to any element, be it gold, carbon, or oxygen. To really understand the definition and chemistry of an element, we need to know exactly what is inside one. Elements are made up of many atoms and molecules of an element are made up of similar types of atoms. But what do I mean by similar types of atoms? Well, atoms are made up of three components: electrons, protons, and neutrons. Every atom that belongs to a certain element will have the same number of protons in its nucleus. All atoms of an element then have the same number of protons, but the number of neutrons can change. If two atoms of the same element have a different number of neutrons, the atoms are called isotopes of the element. And examples of isotopes include carbon-12 and carbon-14. Carbon-12, more commonly known as just carbon, is the naturally occurring stable carbon we find around us. Whereas carbon-14 can also be found in nature, but is a radioactive isotope of carbon. We cannot talk about elements without looking at the periodic table. So let's talk a bit more about it. The periodic table shows all elements you find in the world. You might have seen the periodic table at least once in your life, either in your school chemistry book or on one of your favorite shows where the character is a geek, like all of us. The periodic table packs up so much relevant information about each element. It's an essential cheat sheet for anyone learning chemistry. Now let's quickly break it down. Every element in the periodic table is depicted by its respective symbol. Some elements are depicted by the first letter of their scientific name. For example, O is oxygen, C is carbon, and P is phosphorus. Other elements are represented by two letters of their scientific name, such as Al is the chemical symbol for aluminium, and Mg is the symbol for magnesium. The first letter in two-letter chemical symbols is always uppercase, and the second one is lowercase. In addition to that, there are some elements that are represented by their Latin names and not their English ones. For example, Fe is the symbol for iron, and it stands for its Latin name ferrum. The same goes for sodium, which is Na for natrium, and lead, which is Pb for plumbum. The periodic table is further divided into periods and groups. Periods are the rows of elements in a periodic table, and the groups are the columns. If we move across the table horizontally, we go from metals to non-metals. And in the middle, we find heavy metals. And no, I'm not talking about the music genre. Elements within the same group have similar properties. The size of an atom increases from top to bottom within each column. And if we look closer, we can see that each element has a number. That number is the number of protons in the nucleus of an atom of a specific element. And the number has a name, which is atomic number. For example, if we look at helium, we can see that it has an atomic number of 2, which means that every helium atom has 2 protons in its nucleus. Remember that atoms are normally neutral, which means that they don't have a positive or negative charge. So the number of electrons in one atom of an element is also equal to the atomic number. The positively charged protons are offset by the negatively charged electrons 1 for 1. There's more we can learn from looking at a periodic table, but for this video where we're focusing on defining the term element, this amount of information should suffice. Now, one question. What are the most abundant elements in the world? The lightest elements in the periodic table are actually the most abundant elements in the world. Those are hydrogen and helium. Hydrogen is the first element in the periodic table, has a mass of 1, and makes up 75% of everything in the world. While helium is the second, has a mass of 2, and makes up 23% of everything. But what about living things? What are the most abundant elements in living organisms like you and me? Even though there are many elements in the periodic table, living things have just a handful of them. Who knew life was so atomically basic, right? The four most common elements found in living things are hydrogen, carbon, nitrogen, and oxygen. And guess what? We find them all in the air, plants, and water, which are things we, for the lack of a better word, consume. We find other elements in smaller quantities in organisms, talking about phosphorus, sulfur, calcium, chlorine, potassium, sodium, and magnesium. It is common to see elements like sodium, chlorine, potassium, magnesium, and calcium circulate in our bodies. For example, let's look at NaCl, the famous sodium chloride. When it meets water in the body, it breaks down into the ions Na+, or sodium, and Cl- or chloride. Those ions will then be used by your cells to keep your body functioning as it should. And now we have covered the basics of what an element is. There is so much more to cover that cannot be concisely put in this short video. Hopefully we will continue making more videos as we explore related topics in more detail. But do not forget to subscribe to my YouTube channel and like this video. I will see you next time.